Let's get started. I would like to introduce Kaizen's Regional Manager, Ethan Mueller.
Thank you, Sherry. Hello, and welcome to today's Tech to Tech session. Our topic for this evening is the manual methods for measuring the chemical concentration of an aqueous wash bath. Before we get to the couple of methods that we will be discussing tonight, I think there's an important question that we need to address first, and that is, why are we concerned with measuring chemical concentration at all? And this is actually pretty straightforward. Cleaning processes are dynamic. We have exhaust losses. We have parts carrying chemistry and wash solution through our process, and we have chemistry being consumed as we clean. The chemical concentration of our wash bath is changing with time and throughput. And what happens when our chemical concentration falls out of range? We can start to see some undesirable side effects. First and foremost, we can see dirty parts or insufficient cleaning. If we are applying some sort of metal protection, we can experience rusting or corrosion issues. If we're dealing with sensitive materials and/or an aggressive chemistry, we can see compatibility issues such as pitting or discoloration. Or maybe our process is just being a little bit of a hog and we're consuming an excessive amount of chemistry. At the end of the day, each of these issues is costing us money. So now that we understand why it's important to monitor, how do we monitor? And the first method that I'd like to discuss tonight is conductivity. There is a relationship between the chemical concentration of an aqueous wash bath and the conductivity of a wash bath. And this relationship allows us to know the chemical concentration by measuring conductivity. Conductivity is the preferred method. It is a simple test to perform. It's easy to read the meter and interpret the results, and it's an accurate test. Conductivity is applicable with the majority of the aqueous applications that Kaizen is involved with. So it's not affected by those contaminants like oils, greases, and coolants. And these are some of the common things that we're removing from our metal parts. This is the kit that Kaizen uses and recommends for measuring conductivity. It is the Open Conductivity 6+ meter. This is the meter right here. We have some calibration fluids, and we have our replaceable probe. So once we're ready to use this, the first thing we're going to want to do is we're going to want to collect a sample from our machine. And then we're going to want to take that sample and we're going to want to set it aside to cool down to ambient temperature. The conductivity of the solution will be affected by the temperature, so we just want to remove that variability. Once we've allowed the sample to cool down to ambient temperature, first thing we're going to want to do is we're going to want to plug our probe into the meter, and of course, turn the meter on. And then we're going to want to submerge the meter. Both of these metal bands here, we want to submerge into the wash solution, and our meter will generate a reading for us. And it looks like we're at 10 millisiemens. So we're going to take that 10 millisiemen graph that Kaizen develops for each of our products. These graphs are unique to each of our products. This one is for METALNOX M6310. And it's in a process using deionized water. We also have graphs that are corrected for the use of city water. So let's just pretend that we are using M6310 in a process using city water. We are going to follow that y-axis up to the 10 millisiemens. We're going to follow that over to the plotted line, and we're going to drop down to the x-axis, and we're going to see that we're somewhere between 11 and 11.5% concentration. And once we've completed this, we have measured the chemical concentration of our wash bath using conductivity. So the next method that I'd like to discuss is titration. And titration is actually a chemical analysis of our wash solution. We're neutralizing an acid or a base component of the product that we're adding to our wash bath. And we're doing this with the volumetric amount or a measured amount of titrant. And the measured amount of titrant allows us to know the concentration. So titration is a simple method. We are effectively counting drops. However, it is more involved than conductivity. There is a little bit more nuance there. So therefore, it is not as conducive to the production floor as conductivity might be. But it is a wonderful substitute for conductivity when conductivity is not applicable. And that's in those processes where we're removing rusts, oxides, and other ionic contaminants. The those things will skew the conductivity reading and therefore make titration a better choice in these processes. This is a standard kit that Kaizen puts together. This one is for our alkaline products, and they all pretty much look the same. You get your titrant, you get your phenolphthalein indicator, and you get your Erlenmeyer flask, which is the vessel that our test will be carried out in. And once we are ready to take a reading, the first thing we're going to want to do is we're going to want to collect a volumetric amount of wash solution from our machine. And we want to be as accurate as possible here because this will impact our reading. From there, we're going to dilute it with some water. We're not so concerned about the volume of the water that we dilute with. And then we're going to add the indicator. Once we've done all of this, now we're ready to titrate, and we're going to add our titrant drop by drop, and we are going to count every single drop that we put into that Erlenmeyer flask, and we are going to add the drops until we see a sustained color change. So going from clear to pink here, and let's just pretend that it took us 13 drops to get there. Is we're going to take that number 13, we're going to plug it in to our equation up here, 13 drops times the factor, which is 0.41. And we're going to see that we're at 5.3% chemical concentration. Otherwise, we can take it over to the table and we can drop down to 13 drops, move over to the concentration column, and we see that we are at 5.3% concentration. Kaizen does provide both the table and the equation. So feel free to use whatever you or your operators are most comfortable with. And once we've done this, we have measured the chemical concentration of our wash bath using titration. So a question that I get quite often in the field is, can I use pH or a piece of litmus paper to measure the chemical concentration of my wash bath? And as you see from this example, unfortunately, the answer is no. And this is pretty common for most of our products. This is an example of METALNOX M6310, which is an acid product. But if you'll take note here, from what I'm going to call 0.1% to, let's just say 2%, you see a very drastic drop in pH. And then from 2% all the way down to 16%, we see virtually no change in pH. So unfortunately, the relationship between pH and concentration is not one that tells us too much. So now we have measured our concentration, and we noticed that our bath is a little low. Now what? Pretty easy, straightforward. All we have to do is add some makeup chemistry, and we have to do a little bit of math here. We got to know how big our wash bath is and what concentration we want to we want to bring our bath back into range. And this is a perfectly acceptable practice. Every single one of my customers using an aqueous product adds makeup chemistry when their concentration falls a little low. However, we cannot add makeup indefinitely. Our wash baths do age, as you can see from this picture here on the right. Concentration is not going to tell us when the bath needs to be replaced. So tech to tech is not on bath life. There was a few tech to techs that we did do on this topic. So I would encourage you to go back if you are interested in learning about these specific topics and reviewing those tech to tech presentations in the library. But I'll just make a quick mention of the two tests that we do use for bath life. And the first is alkalinity ratio. And that is essentially telling us how efficient our chemistry is when we add it into the bath. And this requires some specialty lab equipment, a burette and a pH probe. And then we have NVR, or non-volatile residue, which is going to help us understand soil loading. And this also requires some equipment. So this brings me to my final topic, final thing that I think is worth mentioning, and that is the idea of keeping a logbook. Keeping a logbook is going to allow us to reflect back onto our process if we see any downstream issues, any finishing issues such as plating issues or painting issues, or maybe we see some rusting. We can look back at our notes and see if maybe the wash bath has anything to do with it. But ultimately, it's going to help us learn about our process. It's going to help us optimize our process, and it is going to help us get the cleanest parts and the most bang for our buck. So, in summary, why do we want to monitor chemical concentration? We want a consistent process with clean parts, and this is ultimately going to provide us a cost savings. How do we monitor? We can use conductivity, which is Kaizen's preferred method, or we can use titration, which is a good substitute for conductivity. If you're interested in learning about automating your chemical concentration monitoring, if that is the case, then I would encourage you to tune in on November 5th to learn about Kaizen's conductivity control system. And with that, I'm going to turn it over to Sherry.
Thanks, Ethan. If you would like to discuss this topic further, please contact your local Kaizen regional manager or send an email to tech@kaizen.com. And we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.